And today might be a quicker lecture. I'll just go through the slides, and we'll be done with that. AJAX, we're not going to necessarily do AJAX. I might give it to you in front-end code. I honestly don't think I will, though, but if it makes sense, I might. And polling you won't have to use in this course. We're going to use WebSockets instead, but I'd be doing a disservice if we didn't talk about it, at least. So we do need to talk about what AJAX and polling are, so you know what these things are when you run into them out there in the world. So we have a website where users can upload files and share those files with other users, and they have some interaction. But we have one kind of downside to this is we require a page reload every time, well, two downsides. We require a page reload every time somebody submits, and to get new information, we must reload the page by some user action. The user has to take an action, usually a form submission, before they can see the other messages. So if somebody just wants to lurk in the chat on your site, they can't really do that. They have to send a message or click refresh the page to be able to get the new chat. They can't just sit back with their popcorn and watch the conversation happen. Can't do that right now. So what we want is this. We want to update the content of a page without refreshing the page, without having to reload the page, especially without requiring user action. We want this to happen in the background. So what we want to build is effectively a chat app where that's exactly what we can do. We can get the chat history and the new messages as they're happening. We want live chat. That's our overall goal. So for that, we're going to use AJAX. The acronym is kind of outdated. This asynchronous JavaScript and XML. It's really just asynchronous JavaScript at this point. So what we have here is JavaScript that's going to make an HTTP request after the page loads. So once the page loads, we make an HTTP request using JavaScript, and that happens in the background after the page loads. We can do this with get, posts, and the other methods. I didn't list them all here on this slide, though. And it looks like this. So we're going to create a new XML HTTP request. Again, kind of an outdated name, but that means give me an AJAX request. And then we're going to populate that AJAX request with all of the information of what we want to happen for this request. So we create the request. We're going to open the request by giving it a method type and a path. And then when we send the request, that's going to fire off this HTTP request off to the server. When we get the response, we're going to use this block of code to be able to determine what's going to happen on the response. This method is a callback that happens whenever the ready state of the request changes, and we're interested in one particular ready state when we get a response code of 200, meaning everything went okay, and a ready state of 4, which means all of the data was received. There's no buffering anymore. We're not waiting for a response from the server. We got all of the response, and we're ready to process it. If both of those are true, we have the response, we have access to that, and we're going to do whatever we want to do with it. In this example, all I'm doing is printing it to the screen, but this is where you would process this, render it to the page, etc. If we want to make this a post request, we change the method to post, and when we send, instead of giving it no parameters, we're going to give it the data we want to send. In this case, I'm sending a JSON string, very common to send JSON strings with these requests. The web, we really like JSON on the web. It's a nice, convenient way to communicate complex information in string format. But why do we want to do this? Well, it solves those problems we talked about on the first slide. We're going to get interaction. The big thing is the interaction, the live interaction. But there's also another way this is used. You've seen this all over the internet these days. The modern web uses this for faster page reloads. When you make your initial request, you're getting almost nothing. Well, the first HTML that comes back, the page renders, and there's like no content there. You see this all the time when you go to a website. There's no content there. but the page loads really fast, even though there's really nothing interesting to look at. And then once the page loads, the JavaScript load starts running and starts making AJAX calls for all of the data. You get the data and then start populating that data on that front end after you receive those AJAX responses from the server. So you see the page loads, there's nothing there, and then the content starts populating all over the place. This gets us a faster time from when you click on a link to the initial page loading. And as long as there's something to look at, users are less likely to navigate away, is one reason why we like this. If you have to wait for all the information, all the content to populate, like we're doing on our servers, where we're rendering all the HTML server side and then sending it all, it does take a little bit longer to get to that first thing that you're looking at. Users have to just look at a waiting symbol, a loading symbol for a little bit longer. So this gets us a fast page load, and then the data populates afterwards. This is very common, and then instead of HTML templates, the data is sent using an API. The data is usually just big old JSON strings, and then the front end is going to parse the strings and populate the front end of the page. So this is the opposite of using HTML templates. Usually this is the way the modern web is going to work, is having AJAX calls to get the content, and the initial call is just going to get the structure of the page, and the JavaScript, which is effectively the template engine, but it's going to be client-side, and the client will render all of the data, will render the templates. And we don't have any page reloads. So those page reloads, if you're sending a submission and the page reloads, well, we have a lot of issues. Bandwidth, you might have flickering as the page constantly reloads. It's going to clutter up your browser history. Your back button is going to be populated with all kinds of stuff. We can also stream with this using AJAX calls. This is how, for example, Twitch works. We're going to have a lot of AJAX calls to get all the information for the video that you're currently streaming in YouTube. You're going to constantly make AJAX calls. If you look in your network tab as you're visiting one of these pages, you're going to see that all those requests for all the extra information. All right. Sorry about that, everyone. It's been 5.5 years. I think that's the first time I walked away from a lecture. We had a life or death situation there. All right. Wait, I'm exaggerating. Please don't take that seriously. All right. So let's talk about this. So AJAX is going to give us some benefits, a multitude of benefits. We avoid those page reloads. We get a better user experience. We have faster page reloads. And we can get close to at least live chat. We can get live interactions between users. That's our ultimate goal with this conversation. Our solution will be WebSockets in this course, but that's our ultimate goal with these things. So we can also change the encodings for what it's worth, if this is something you're into, which you might be. Instead of on a form using the encoding type of multipart, using the multipart form encoding, we can change the encoding, but we'll do that next. We can use multipart form encoding and then use an AJAX request to make a form submission by, instead of just using the built-in HTML functionality of sending the request, getting the response, and then loading the page with the response. For the homework, that response is a redirect, and then you redirect to the home page and render that home page. Instead of that, we're going to create an AJAX request by overriding the onSubmit functionality. Instead of using the default HTML browser functionality when you submit a form, which is send the data as a request, reload the page, we're going to override that. Return false says don't do what you usually do, and instead call our function, send message with form, which will be on the next slide. So that send message with form, we're going to call this function when the form is submitted. So whenever you click that submit button, this method is called, and we don't get the usual behavior of a form, which does reload the page. So with this, we're going to explicitly get the form element, create a new form data object with that element. That's going to give us all of the form data. We're going to create our AJAX request, and we'll omit all the ready state change just because it clutters up the slide. And then create a post request with that form data. This is going to send that form request, that form submission, in the same format as we've seen in Homework 2. You could do this in Homework 2 and submit the form with an AJAX request instead of having the page reload. It gives you the same functionality, but we can do it through JavaScript instead of using HTML, the default functionality. And we don't have to use forms at all, even. So when we submit data, it's using a form. It's literally form, multi-part form, URL encoded, or plain text, which should never be used. Those are your three options for encoding the data, and that's why we use this multi-part form stuff on Homework 2 instead of, say, a JSON string with base64 encoding for the image. That's the reason we do that, is that's all we know how to do in Homework 2 until we know some AJAX, is those three options. That's the only three things you can do with a form, the only three encodings you can use. But with AJAX requests, we can just bypass the forms entirely, and instead of having a form that we're going to use and submit using this form tag, we can create our own forms and just put our inputs and a button instead of an input of type submit. We can have our form elements just be contained in our own kind of custom form. So here I have a chat input and then some button that's going to call send message, but no form. So I don't get the HTML behavior at all of submitting a form. We allowed to use Axios or Fetch API for future homeworks? I'm not 100% remembering what those are. Are those databases? In my opinion, what's better, Flask Django or Fast API? I haven't used Fast API, but Flask over Django for sure. I hate Django with a passion. Django's fine. I'll give my opinion on this since it came up. Django's fine for like your first web framework that you use. Django does a lot for you by magic. It just magically does everything. If you're using it for your project, I'd recommend to not do that because the reports are very, very difficult because you have to dispel all of that magic and figure out how the hell Django actually works. But it works by magic and just says, trust me, do it this way, and I'll do the rest for you. The problem with Django is once you get beyond your first framework and you want to start adding more custom features, Django just doesn't let you. If Django doesn't do it, you can't really do it in Django, at least not easily. So to add any custom stuff that that doesn't fit like Django's cookie cutter of how to do things, it's really, really difficult. I like Flask because it's just a bare minimum. They call it a micro framework. Bare minimum just kind of does what it needs to do and then steps out of your way. And then you can just use all of your programming skills to get the rest done. And then whenever you need to do some extra web stuff, you say, hey, Flask, how do I do cookies? And then it'll say, oh, yeah, you just call set cookie. And then you go, thanks. OK, step out of my way again. So Django, so in summary, if it's your first website, Django's great. You follow the Django tutorial, you can do really powerful things really fast. But once you advance to a certain point, Django's going to start pissing you off. So assuming Axios and Fetch API, assuming those are databases, you technically can use them as long as you're still using Docker Compose and 2 containers. And then you would have your second container just connect to your databases. But I do want everyone using 2 containers. It's something you'll have to do out there in the world, in the real world. All right, so we have this kind of makeshift form. We have our input, and we're going to call send message when this button is pressed. This button is going to find the elements for just one in this case. Find the element for the input where the user submitted their chat message. Get the value. That's going to be whatever the user typed in. That's going to be the value of a text input. And then we're going to manually create our JSON string containing that message. So if you want your AJAX calls to be working with JSON, this is a way to do it. Create your own custom forms and don't rely on HTML's way and the browser's way of doing forms with this multi-part encoding or URL encoding. Honestly, URL encoding you shouldn't really be using because it's a pain to work with. Plain text you shouldn't use only in debugging environments. So you're pretty much stuck with multi-part form parsing, which is fine now that you have your parsers written, assuming, well, a lot of you might not. But if you have your form, multi-part form data parser written, after that, it's not too bad to use that format. But it's cumbersome, as you know from homework too. It's cumbersome to deal with, at least the first time you're writing your parser. And we like JSON. JSON, we get this on the server, and we say json.loads or json.parse, depending on what language you're using. Parse that JSON, and you have all the data right there immediately available. We like JSON. Make H from Node. Wait, why would you want that? Axios is a JavaScript library used to make HTTP requests from Node or AJAX requests from the browser, and it supports the Promise API native to JS be used. Except HTTP requests. I mean, from that description, I don't see anything that I wouldn't allow. My bigger question is, why do you want to use those? So it has some front-end functionality, but I don't care about front-end in this class. So I'd be okay with that if you just get different syntax for sending your AJAX requests. Sure. And why do you even want to send requests from Node? Well, will there be slides for WebRTC before the break? During the break is when I'm going to make those slides. So somewhere during the break, you'll probably get the first set of slides at least. I don't know. I'll hold off on that question. If you want to DM me or send me an email to make sure I remember to look into it, see if that's allowed. Then I'll add it to the, just a reminder if anybody hasn't heard this yet. In the project requirements document, I should probably make this a little less hidden, but in the project requirements document, there's two lists, the allowed without reports and not allowed libraries, or not allowed unless you write a report. Those are the same for the homework. If they're allowed on the project without a report, that's the same as being allowed on the homework entirely. So if it's allowed on the homework, it's allowed on the project without a report. And if it's allowed on the project without a report, it's allowed on your homework. So if you look at the project requirements list and everything that's allowed without a report, you can use on your homework explicitly. So I'll look into this, I'll make a decision, and then add it to one of those two lists. If it requires a report on the project, it's banned on the homework. Which I'll make more clear. I should probably just put that on the website itself instead of having you click into a document to find it. Yeah, Express is a lot more like Flash than Django, but yeah, it's the same idea. It's a web framework. I like Express. Since it is a lot like Flash, it does what it needs to do and gets out of your way. Honestly, Express doesn't really do much of anything at all. Flash, so Node has a built-in HTTP library, and most of what Express does is just uses that library, and then it adds the idea of middleware on top of it. So the idea of middleware is what Express is bringing to the table, and not much else. If you actually look through the Express library, the source of it, there's almost nothing there. It's a very, very lightweight library. But I like it, nonetheless. I like the idea of middleware, so I enjoy it. Where can we find that allow library list? On the course website. If you go to project requirements. Libraries that do not require reports. So these are all allowed on your, these are students asked, I reviewed them and over the semesters and said these ones are explicitly allowed on your homework. JSON libraries, TCP libraries, database connection libraries. Not ORMs though. Hope I have that in here. Database client libraries. I can make that a little more clear. But that's that list. So I'll add that to one of those two lists when I look at it. All right, I got ahead of my slides a little bit on the rendering content. I kind of talked about this already. But we have this question of when to render content. Right now we're rendering everything server-side and shipping the final HTML to the client. But with AJAX, we have another decision. We can send raw data from our server and then have the front end render that data. This is where you get front end frameworks that are really powerful in this sense. And it's kind of a question to trade off. I think most modern websites are doing client side rendering. I don't know if any of that are doing server side rendering still. One trade off here is who's spending the CPU time to do the rendering. Have all your clients do it or have the server do it. If the server does it, that's a lot extra load on your server, but if the client does it, that's a little bit less performance on your websites. But most sites are going towards, let's make the client do the rendering. I gotta have this slide again. Where can we find, oh, I already answered that. And this is probably one of the biggest points here is what if you decide to do server-side rendering like we do in homework 2, and then you decide one day that you want to build a mobile app in addition to your web app? How do you do that? Your mobile app's not going to render HTML unless I forget what it's called, but there's a way to do it to package your website and just turn it into an app. But it's slow, it's bulky. It's not the best thing to do. Same with desktop apps. I believe it's Electron. You can take your website and just package it as a desktop app by basically running another instance of Chrome. It's very bulky, very expensive to do, but a lot of modern apps do that. That's why every app we ever run takes at least 1 gig of RAM to run, because it's all running basically another instance of Chrome. But if you have everything rendered as an API and your server is just rendering the data for the most part and like the basic structure of the HTML, now to write a mobile app, you go to the mobile app and you write the structure, a mobile native structure for the app, and then connect to the same API. Get the same data, the same information, the same way the web does. And since it's just JSON, you can consume that from any device. This is how an app like Netflix works. Netflix, the API, or most modern apps, the API is going to serve the content, serve your videos, have an API endpoint to give you the list of action movies that are popular at the time, your recommended and all that stuff. That's all API calls and probably served as JSON strings. And then whether you're on mobile, the web version, a desktop version, if you're on your Xbox, on a Roku or whatever, they just write a different client for each one of those that just displays the Netflix page native, in a way that's native to that device, and then connects to the API, gets the data, and renders it in a way that's native to that device. So the main Netflix server is still going to be used by every device, and then they can quickly roll out, a new device comes out. Apple TV, okay, we got to write a new app for this. They don't rewrite all of Netflix for it. They just rewrite how to lay out the structure, and then they connect to their API, and all that API code, all the algorithm and all that stuff, it's all the same. Authentication, things like that, it's all the same. So using this API method, we can deploy to multiple platforms without rewriting our entire everything, our entire server. So we just serve raw data and let the client take care of that data and render it in whatever way they want to render it. Which, of course, the client will be written by us as well. But we'll write each client for each device, not a whole new server for each device. Okay, but we didn't really get to live interactions yet. In fact, we won't really get to it. I guess we kind of do by the end here. But how do we get live interactions between users? Well, polling is one way. With AJAX calls, we can make those requests to get the latest data. We can make an AJAX request, get more data from the server, and say, hey, are there any new chat messages for me to see? And then the server responds with any chat messages that might be available. That's fine, but how do we trigger an AJAX request? Do we still ask the user to press a button to fire off an AJAX request? Well, that defeats the purpose because that button they press might as well just be the refresh button. We need this to be automatic. That's where polling comes in. Polling says, well, let's just send an AJAX request at regular intervals and just keep sending them. So with polling, we're going to do something like this. Set interval is a JavaScript method which is going to call a function. This takes a function and a number of milliseconds, and we'll call that function every time that many milliseconds passes. So in this case, we're going to call get messages every second. So every second, and then get messages is our get messages method. Actually, did I even show get messages in these slides? If not, I mean, you can imagine what it does. It fires off an AJAX request, gets all the messages, and renders the whole chat history to the page. So every second, we're going to fire off an AJAX request that's fired off by the get messages function and render the new messages to the page. Now, every second, hey, server, you got something new for me? Hey, server, you got something new for me? Hey, server, you got something new for me? And we're going to just keep asking the server. We're going to keep asking it forever. Now, this gets us close to live. We have, at most, that number of milliseconds, 1 second to wait. In this case, somebody types a message, hits enter, sends it to the chat. The maximum you'll have to wait is 1 full second to see that, which isn't terribly long, but honestly, I want more performance. It's freaking 2022. I want more performance than that. I want to see that message immediately. We're also used to seeing so-and-so is typing. You know, we want that information. If we have to wait a second, like by the time we know they're typing, they sent the message. I don't know. I want more performance than that. We can demand that, right? And we can build that. We can deliver that to our users. We want more than that. So it's good, but not great. And this really clutters up the network. This is a lot of requests. I actually DDoSed myself accidentally using this approach. I had, it was a 1:15 lecture. I set up a live website. It was just a chat app. It was very simple. It was the lecture example. And I had the students chat in the chat app. It was using polling. I believe it was set to 1 second. And I had it deployed on my DigitalOcean account. And, you know, hundreds of students registered, probably 100 showed up, and maybe 50 actually opened the page by my estimates. But 50 students firing off requests once per second. We got 50 requests per second. We got I can't do math right now, 3,000 per minute over an hour-long lecture because they'll open it up in a tab. Some of them open multiple tabs and stuff, and just leave it open. So we were firing off, and it ended up being over 100,000 requests over the lecture. And DigitalOcean said, holy crap, you're getting a lot of requests from University at Buffalo. I'm shutting them down and not allowing requests from UB anymore, and from any one of these IPs in the UB range. DigitalOcean actually detected the DDoS attack and shut it down. I'm like, no, I was the one who did that. I wanted them to do that. So during lecture, they're like, your site's not working anymore. It's because we DDoSed it. If anybody's not familiar with that term, DOS, denial of service attack, it's where you flood a server with so many requests that it just shuts down. DDoS is a distributed attack like that, where you have many devices attacking the same server. by just flooding it with requests. So we flooded the server with requests. DigitalOcean detected it. Its DDoS prevention software kicked in. The algorithm said, hey, you're getting DDoSed. I'm going to block all this DDoS attack for you. You're welcome. And I'm like, wait, no, I wanted those. I wanted those requests. So it's going to send a lot of requests. Was my math right there? Was that over 100,000 throughout a lecture? 50 students once per second for an hour? Right? I think it is. I think my math's right. Math's hard. Since nobody's confirming or denying, let's, shit. Now I'm leaking information. 50, so say, oh my goodness. So say it was 50 students, 3,000 requests per minute. Yeah, 180,000 requests over that lecture, assuming it was an hour, assuming like they left their laptops with that tab open after lecture and stuff. Over 100,000 though, for sure, with just modest estimates. You know, if most of the class actually went to the page, you know, it's going to be 250,000 requests. A lot of requests. So, yeah, polling's not great. And you can change this. I mean, you can change this number. Okay, I don't want that many requests. Let me change this to 5 seconds. Well, now you might be waiting 5 full seconds to see a chat message or whatever you're using polling for. That's way long. Like with a second, you can reasonably say, look, you can wait a second for your messages. 5 seconds? I don't know. It's a long time. But it is easy to implement. It's literally this. Like you just call the built-in set interval and it just fires off the requests. Assuming you implement get messages to fire off the AJAX requests and render the response to the page. But very limited, very bad. So enter long polling. 1 millisecond, yeah. You'll have issues at 1 millisecond, to say the least. And yeah, that's the other, I forgot to say the other side of that. You can lower it to like 100 milliseconds fairly reasonably, but then we're hitting, instead of 100,000 requests for 50 users in an hour, we're getting 1 million requests. And that's just modest usage. What if you have 10,000 users who are using your site 24/7? That's a lot of requests. You're talking billions at that point. That's not feasible. It's not maintainable. And it's just not a good idea. So enter long polling. This is a better solution. This solution we like a lot more. So long polling, which would be, I think it'd be fun, but I don't know for who to actually have you do long polling in the course. I don't even know if I'd enjoy watching you go through it. I don't know if it'd be fun for any of you. Until you get it working, then it'd be pretty fun. But long polling is where the server intentionally hangs on requests. So you effectively enter a loop where you just say, I'm just going to wait. So you get a request, and if you don't have data to send the user, the user says, hey, give me any new chat messages that I haven't seen yet. And the server, if it doesn't have any chat messages, just waits. So you better have concurrent code on your server at this point, because you're just going to wait on that request. Hopefully you can handle other requests while that's happening, would be the trick in the assignment. You just wait. And then if a new message comes in, some other user sends a message and says, hey, I'm sending this to the chat. Then as soon as that message comes in, you respond to that message that request that you're waiting on. You say, hey, yo, I got your response. You might have been sitting there for like 5 seconds waiting, having that request, and then you get a message, and then you respond. But the server intentionally hangs. This is the idea. And this is because HTTP is a request-response protocol. The server has no way of saying, hey, clients, I got some information for you. Because there's no clients, there's no connection. A client connects, sends a request, you send a response, you close the connection. You send the HTML, they create another connection. Hey, I need some JavaScript. You send the JavaScript in a response, you close the connection. Now there are ways to like keep the connection alive and have multiple request responses over the connection. But once you're done with those requests and responses, you close the TCP connection. That's just how HTTP is supposed to work. So long polling says, no, send me a request, and I'll keep that connection open until I have something to say. These will time out, typically about 10 to 20 seconds. If there's no new data, the server is going to say, look, this request timed out. I got no information for you. And once the client gets that response, immediately sends another request, and server goes back to hanging. So now if there's no action on the site, nothing's really happening, now you're getting a request every 10 to 20 seconds, which is more manageable. We can handle that amount of traffic. We got 10 times less traffic than we had with regular polling in these examples with these numbers. So now, in effect, the client always has a request pending on the server, and when the information comes in, they get that response. Even if they get new data, they're going to send another request immediately. Each client should always have a request pending on the server. And this is still used in industry. I think that's my next slide, right? You will still see this in industry. It's used fairly commonly, kind of famously or notoriously, I don't know what to say, but Facebook chat still uses long polling to get the job done. They don't use WebSockets or anything else. It's still long polling in that. The developers said, they're on record saying, well, WebSockets would be fine, but it ain't broke, so we're not going to fix it. So they're just sticking with long polling because it was written before WebSockets existed. So you're still likely to run into long polling out there in industry. We're going to use WebSockets, though. It's more modern. WebSockets aren't even that new anymore, but they were invented after Facebook existed. I don't know, before Facebook chat or after Facebook chat. So it is a more modern solution, but you will run into this out there in industry. There are a lot of apps that still use this. And you can see if you go into your browser console, you can see the long polling requests on anything that uses long polling. You'll see a request that takes 15 seconds to get a response, and then immediately another request with 15 seconds to get a response. And then whenever there's action on the site, those responses come a lot faster. You'll be able to see that in your network tab. And any browser, this is less relevant these days, but any browser that doesn't support WebSockets, they can still use the long polling. These days, I don't know, it's such a small subset of users that I think we'd be okay. I think we'll be okay. All right, so any questions? As promised, we're back at the lecture question in case you didn't have enough information to get it the first time. Once you submit this, you can go and have a great week. I'll see you Monday.